Hey, I thought we could have a bit of fun and actually model the physics, something that scientists, physicists do all the time. So here is my model drink tray and my fingers and my thumb, and there is my drink that I put on the tray. And already I can feel when I load up that drink there that I'm having to push down harder with my thumb and therefore harder with my fingers to compensate for that. My arm is providing an upwards force against the weight of the tray and the drink combined, but I can feel a lot of tension here as I'm trying to pull down on my thumb and up on my fingers. So a bit hard to kind of see measure what's going on, so I thought we'd model it. So here is the model of my hand. These will be my fingers, that bolt there will be my thumb, and I'm just going to zero all that so we can have a look and see what's happening. So if I put my tray here, you can see the weight of the tray represented by the scales there, and I add my drink to that and you can see it go up. So by modeling like this, we're effectively doing that vector sum of the downwards force and the upwards force. All we're looking at now is what's the overall force on the drink and the tray. And the overall force on the drink and the tray is just simply the weight of the drink and tray. So when I move the drink further out like that, there is no really significant difference in what the scale's measuring. But if we now just turn things around a little bit, and instead now let's just measure the force, upwards force from my fingers. So I'm just going to tear this, and my thumb force will be provided over here with my other hand, which is going to be pushing down, fairly hard to provide that downwards force here. Okay, so already you can see that the upwards force that the scales have to provide is greater than what the original drinks tray force was. And when I put my drink there, I have to apply quite a hard downwards force on my thumb here, and that's increased the force on the scales. But the sum of those, right, the vector sum of the downwards force from the thumb and upwards force from the scales is going to result in a resultant upwards force, which is exactly the weight force of the drink and the tray. Anyway, as I move the drink out to that further position, you can see that I have to push harder down with this part to keep the thumb pushing downwards, but you can see it's massively increased the finger force. And so both of the forces go up, but their vector sum is still going to be the weight of the drink in the tray.